Tallulah Dogwill.
And I'm Grace O'Brien, and this is our science project.
The title of our science project is Reducing Carbon Emissions by Creating a Light Fixture that Relies on Solar Energy from the Indoors.
We chose this project because we were learning about CO2 emissions and our carbon footprint in science class, and we wanted to make a difference. The long-term goal for this project is to reduce the amount of light energy Breck School wastes in the process of reusing this energy through indoor solar panels.
Electrical grids right now are like 99% of the time run on natural gases. And in the process of using natural gases, they emit a lot of CO2 in our atmosphere, which further contributes to global climate change.
We needed a way to reuse energy along with not using an electrical grid. We thought of indoor solar panels, which have never been used to power an indoor light fixture before. Solar panels take photons from an energy source, for example, the sun, and reuse it to power a second energy source, like lights and power and all that stuff.
Although we had this idea, we had to figure out a way to measure if our project was successful or not. It's hard to measure the amount of CO2 a certain thing emits, so we decided to measure the volts being transmitted and reused over a certain period of time throughout our solar panel circuit. So basically, our engineering goal is to build a light fixture that uses the excess energy from another light to power itself.
How the circuit, basically what it does is it takes excess energy from the first light source that will be used to reduce CO2 production of the second light source.
And then, if we can take this small step for Breck eventually, that means if we could eventually install this in each of the classrooms, we can help reduce the amount of CO2 emitted by Breck, and that can make a big difference in our world. All right.
This is our hypothesis. Our expected outcome is that we can make a light fixture powered by interior solar panels that will be able to lower the usage of electricity for powering light bulbs greatly, while reducing the amount of CO2 emissions being released into the atmosphere.
So what makes our project different is that the solar panels are indoor. I know this was kind of said earlier in the presentation, but this is a big part of our project, and actually 100% of the time, based on our research, solar panels have not been used to power indoor light sources, except from the outdoors before.
Yeah. Okay, so the main materials that we used were a multimeter, a monocrystalline solar panel, which is the most efficient solar panel open to the public, copper wires, a charge controller, a wire cutter, a screwdriver, a battery tester, and 2 light fixtures.
And for the data collection, we will explain that later on in our data collection slides. So this is our plan for the 2 methods that we were planning to use, and we ended up using one of them.
Method 1 was creating a circuit without a battery. So our initial plan for that was to have the first light fixture connected to the solar panel, connected to the other light fixture. The idea was that this would transmit the extra energy from the initial light and reuse it to power a second light bulb, but this did not work.
So basically, a couple important dates in our experimentation was first the 13th of last year, and this day we tried to make a circuit without a battery. It obviously didn't work, but we concluded that this didn't work because the light bulb we were using used watts, not volts, which the rest of our circuit relied on. And the second one, we tried to create a circuit with a new light bulb that uses volts. It also didn't work, and we have some reasons that's not completely determined, but we decided to go back to a battery type circuit. And basically what we concluded also is that the solar panel is not getting enough energy to power the light bulb without a battery.
Okay, the next important date was the 17th. The second plan was to add the battery in the circuit. So it was light fixture connected to the solar panel, connected to the battery, connected to the other light fixture. First important day was the 17th of November. And what we did was the battery had charged 0.88 volts and it was not working. And we tested it on multiple objects and it wasn't working. So this was important because why it didn't work or what was important. It was just basically we had to know
if the battery's not working. And for this one, it was actually an older battery that was not working in the first place, so we knew that it didn't work. And also, to summarize the second one, the light comes into the solar panel, and then copper wires take the energy from the light connected to a battery, and then it will add charge to the battery, and then the battery uses copper wires and transmit energy to the light bulb. So you want to do a second?
Okay, the second date was the 29th of November, and we decided to measure different light fixtures and the light they produce compared to where the solar panel was. So we just kind of went around and measured a bunch of lights and just to kind of collect some data to see what we should buy. Then we came to the conclusion that the optimal height of the solar panel from a chosen light fixture about 34 centimeters.
Yeah, and because sometimes if it was too close to the solar panel would not take in as much as the optimal energy as it could, and sometimes if it was too far, the solar panel also could not. All right. One of the last important dates. What we did is we bought a new battery, the same type as the old one, but we had concluded on the first important date that the old battery was not working, and we constructed a circuit connecting the light fixture to the solar panel to the battery and to another light fixture. Then we measured how long it would take for a battery to charge/lose battery. This was the first time that our light fixture turned on and worked, and we concluded that the battery drains very fast in the first 30 minutes and then it slows down. So this was very important to our data analysis and collection.
So here are a couple of graphs that we made
for our data analysis.
So the first one is the battery charge increase. So on the right, it's the volts that increased, and then on the bottom, it's the hours. So as you can see, it goes up significantly, and then by 100 hours, it has gone out about 12 volts.
So this is after we had measured multiple points and we had averaged it out.
Yes.
All right, so the second graph shows the battery charge decrease. And basically what this is showing is that they're very similar, but on the left side it shows that it goes only up to 2. And this is because the battery decreases a lot slower than it increases, which is really good because that means that the battery will always have charge in it, or will always have enough charge to charge the second light fixture.
Yeah, so basically, to summarize it, in about 100 hours, the battery charge will decrease by 2 volts.
One second, there we are. Okay. That was the data analysis, and now we are on to the conclusion. So,
clearly, solar panels can be used to benefit our environment in ways other scientists have and have not yet discovered.
Climate change is largely caused by emissions of CO2. Things like light fixtures use fossil fuels.
Yes, and solar panels use photons for energy, which is a much better alternative
than relying on fossil fuels. All right, so indoor solar panels rely on reused energy. So initially, the first light fixture will technically have to run on fossil fuels, but we can eliminate this by reusing the energy from the first light fixture for a second light fixture, and so on. So this will basically cut in half or more the amount of fossil fuels produced by using indoor light fixtures if you choose to use this option. And then engineering goal, that was basically a recap, and we feel like we have definitely met our engineering goal in a way that we've actually exceeded it because the battery decreases a lot slower than it increases. All right, thank you for
Watch.
watching.